In this video, I'm going to continue with composition of functions, but I'm going to focus on the domain and range, mainly the domain, but range kind of rears its ugly head here and there, especially with composition. So, if you remember what I said before, if we look at these functions, say if this is my f of x, which I said was 3x plus 5, my input is based on the domain. And if I look at 3x plus 5, that's linear. We said that the domain was going to be all real numbers. And make a bad infinity, right? And the range, the output, is also going to be all real numbers. If I look at this one, this is a quadratic for g of x. May as well look at all these while we're thinking about it. It's a polynomial, so the range or the domain is again going to be all real numbers. The range, since this is a parabola, it's a positive leading coefficient, is going to open up something like this. It's going to have some minimum value. So let's just do it this way. G of x equals x squared plus 3x plus 2. And if I look here, my minimum value is a negative 0.25. So you'll see my range is going to be anywhere y is greater than or equal to negative 0.25. Oops. So we'll come again, negative 0.25. Oh, and my pen is not the right width again. I hate that. Okay. Negative 0.25 infinity. For this one, this is a square root. It's going to look basically like that. It's going to have a limited domain because we can't have the square root of a negative number. So on this one, smallest value x can be is a negative 4, but it can equal a negative 4, and it's going to go to infinity. The range is going to be 0 to infinity. I should make that just slightly thicker. There we go. So with our functions we're looking at here, we have those set up already. Let's look at, we're going to look again the operations and then look at composition with this, with domain and range. So if I wanted to do let's just go f of, we'll do it this way. Change my mind, right? F plus h of x. So we take a look at f of x. Oh, come on here. We got that right. I have my function g of x. Oh, no, not g, h. Remember what you're doing. Okay, now I remember what I'm doing. H of x was the square root of x plus 4. And on here, my input has to be from negative 4 to infinity. My output has to be, well, my output will be a positive or a non-negative value. But when I add these together, let's go back here. I take my output here, 3x plus 5. and I add to this, close, square root of x plus 4. This one's a little bit obvious because nothing really, I can't combine any of that together. But my domain is still going to be, I have to say what I can plug in, I'm plugging the same number. This x goes here and goes here. So it has to be part of this domain and part of this domain. Since this is everything, but this is limited, I'll go with that domain. -4 to infinity. Again, when we're doing these function operations, we deal with each one separately. So we look at each of their domains separately. But since x has to be in both of those domains, we look basically where these two overlap. And where they overlap, we're going to say those values will work. You can see that maybe a little easier if we look at the graph. We said f of x was, and I forget already, which I should remember, 3x plus 5, 3x plus 5. And you can see this is domains, all real numbers, ranges, all real numbers. If we go g of x, h of x equals the square root of x plus 4, here again, x only has to be greater than or equal to -4. If I come now to y equals f of x plus h of x, what's going to happen to this graph? You notice on this black one, when I add those together, this starts at x equals -4. Because when x is less than -4, I can't find a value for h of x, so I can't add them together. So again, that's kind of what's happening on there. We're looking at those separately. Now, let's look at composition. I'll keep these, yeah. Let's just keep this stuff up here because that's kind of nice. If I were to say I want f, and it did that again, it changed, yeah, blah, 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 blah. Yeah, I should be used to this by now, right? If I take f composed with g, we can rewrite that as f of g of x, as we said before. So our picture is going to change now. We're going to first do this g of x. And I don't want to do g, I want to do h. So let me fix this. I should maybe just redo this whole video, but I'm not going to right now. F of h of x. This is inside, so that's the one we're going to do first. H of x. And then the f is outside, so we do that last. F of x. And again, we're going to take this output and turn that into the input. If we look here, though, my input is, I was in blue on this. My input was -4 to infinity, and my output was 0 to infinity. So now this output becomes the input. So this output here, I have to say, how does that compare to this input, to the domain of f of x? Well, 0 to infinity is in the domain of f of x, so I'm fine with that. So I can carry this out, and I can stay with this domain. Even though the domain of f of x is negative infinity to infinity, is all real numbers, we're not putting that in because it has to go through h of x first. The range, I'd have to plug that in and see what happens. I'm not going to worry about the range on this. I'm more concerned at range right here when we're going out of one function into the next function. Now, if I switch this around, if I do h of f of x, so I'm going to first do f of x and then plug that answer into h. Again, looking at this picture, thinking of it this way. This is f of x. This is h of x. And again, I'm going from the output here to the input here. If I go back and I remember, this function is defined for all real numbers. It gives out all real numbers. This function here is only defined if x is greater than or equal to negative 4. And it's going to give me out a non-negative number. So when I pull this in, if I put any number into here, I get any number out, but now I'm going to run into a problem because my input is limited on h to where x is greater than or equal to negative 4. I can't plug all real numbers in. So now I have to say, wait a minute, I need f of x. This is x is greater than or equal to negative 4. So I need this output to be the same as this input in order for this to work. So I'm going to have to say, well, f of x has to be greater than or equal to negative 4. So come back, what is f of x? F of x was, what did I say it was? Go back up, 3x plus 5. So 3x plus 5 has to be greater than or equal to negative 4. So when we subtract 5, we get 3x has to be greater than or equal to negative 9. Divide by 3, I get x is greater than or equal to negative 3. So in order to make this work so that anything that I get out of f of x, I can plug into h of x, I have to limit my domain here to be negative 3 or greater. And if I make x negative 3 or greater, then my output is going to be a value of negative 4 or greater. So then that matches up with my input to h, and everything's happy. I get out a non-negative number, so my domain has to be this negative 3 to infinity. So let's again go back to the graph and see if this really happens. So I got f of x and h of x. When I did f of h of x, I don't see anything. There it is up there. You notice that the domain, again, starts at -4. Which is what we said, nope, over here. If we did f of h of x, my domain had to start at -4 and go to infinity. Looking good so far. If we change this around and we go h of f of x, now we're on this blue graph, and you notice it starts here at -3, and it goes up from there. Which matches what we said before. Because if you look again, h of x has that domain, it has to be greater than or equal to 0. So we look at the range of, or sorry, greater than or equal to -4. So we look at the function f of x, and we say here, where f of x equals -3, y equals -4, that's the first number I can plug into h so that I can get that value. Graphing sometimes helps you look at that and understand it, but the big thing when we're doing this composition, you're looking at the output of the one function is going into the input of the second function. So like on this one here, this had a domain of -infinity to -infinity. Well, if I get out of something between 0 and infinity, it fits in this domain, so I'm okay, and I don't have to change anything. I can go with the domain I started with. But when I come out to say this domain, this range, the output doesn't fit in this domain, I have to limit my input so that my output will match up with this input, so that I can do my second function.